You've probably heard the term turbocharger before, and maybe supercharger as well. You probably also know these have something to do with adding power to a vehicle's engine. But do you know what they actually are and how they work? Let's find out. In the first Engines 101 video, you learned the basics behind internal combustion engines. They suck air into a cylinder, mix it with fuel, and then burn it to move a piston, and then repeat. We then explained the idea of displacement and how larger cylinders usually mean a more powerful engine. That's because they're able to fit more air and fuel, essentially creating a bigger explosion. But there's also another way to achieve this, and it's called forced induction. You see, the engine design we described is considered naturally aspirated, which means it's simply breathing in naturally from the air around it. But the concept of forced induction changes this through components like turbochargers or superchargers. As the name implies, the idea is to force additional air into the cylinders, more than could just be pulled naturally from the engine's intake. By doing this, forced induction can effectively simulate large cylinders without actually having them, enabling a smaller displacement engine to put out the same power you'd typically see from a larger displacement unit. The cool thing here is that it allows for control over how and when it works, meaning that when extra power isn't needed, that engine simply acts like the smaller engine it is, saving fuel in the process. And again, that's because when there's more air, you need more fuel to match, and that's true whether through a turbocharger or larger cylinders. So how does it actually work? Let's focus first on turbochargers. A turbocharger, or simply turbo, can essentially be thought of as a highly engineered fan, compressing and blowing air into the engine as it spins. But what's great about it is that it does this without requiring any power for itself. That's because it's mounted onto the exhaust line, right after the cylinders, so the engine's own exhaust output is what spins it, which in turn pushes more air back into the engine and on, creating a remarkably clever self-powered loop. That said, because of this design, some turbos can suffer from something called lag, which essentially means it can take a moment before the exhaust can get it spinning fast enough for the added power to kick in. Similarly, superchargers also work by forcing extra air into the engine as they operate, but their design isn't quite the same. Instead of being driven by the exhaust like a turbocharger, they're connected by a belt directly to the engine. So when the engine spins, so does the supercharger. On one hand, this means no lag, which is great, but on the other, it means it's taking some energy away from the engine to operate, so the supercharger needs to make up for this deficit first before actually producing any extra power. This means it's not quite as efficient as a turbo, where all the extra power is free in a manner of speaking. Now, just like with engines themselves, both turbochargers and superchargers come in a wide range of designs and configurations. And this video is really just focusing on the general idea behind them. But as an example, the somewhat common twin-turbo design uses two turbos on the same engine. In some cases, they might be identical and simply work side by side to double up on the extra power, generally used in the case of V engines, where there's a turbo for either side. And in other cases, they might be a sequential design, meaning they work one after the other depending on when they're designed to deliver their power. For instance, a smaller turbo with minimal lag for everyday lower RPM use, and a bigger one to max out the power at higher RPM when it's really needed. And there's even some single turbo designs, often called twin scroll, that can vary their output in a similar way, providing the responsiveness of a small turbo and the big power of a larger one, all in one unit. This two-in-one design works by making smart use of the exhaust that spins it, pulling from alternating cylinders in order to create a smoother pulse flow that helps eliminate lag. So that's a quick look at the concept behind forced induction, turbochargers, and superchargers. These fascinating components really take engine design to another level, an engineering magic trick that allows smaller engines to pretend they're larger engines. But as mentioned, this video is just scratching the surface on automotive engines, so be sure to check out the other videos in this series to learn more.